Welcome to this video on vectors. We will be exploring different cases of vector addition. Case 1 involves two vectors of different magnitudes, A and B, moving in the same direction. The resultant vector S is the sum of both components, totaling 25 units in the same direction. This graph illustrates case 1. Vector A has a magnitude of 10.0 and B has a magnitude of 15.0. The resultant vector S has a magnitude of 25.0. Case 2 involves two vectors of the same magnitude, both 15 units, moving to the right. The resultant vector S is 30 units to the right. This is the same as multiplying one vector by 2. Here is the visualization for case 2. Both vectors A and B have a magnitude of 15.0. The resultant vector S has a magnitude of 30.0. Case 3 involves two vectors of the same magnitude, 15 units, both moving to the left. The resultant vector S is 30 units to the left, which is represented as minus 30. In this graph for case 3, vectors A and B are both 15.0 and move left. The resultant vector S has a magnitude of 30.0, indicating 30 units to the left. Case 4 involves two vectors of different magnitudes moving in opposite directions. Vector A is 25 units right, and B is 15 units left. The resultant vector S is the difference, 10 units right. Visualizing case 4, vector A is 25.0 units right, and B is 15.0 units left. The resultant S is 10.0 units to the right, following the larger vector's direction. Moving to the addition of coplanar vectors, place the tail of the second vector on the head of the first. Measure the desired angle and length. The second vector here is 12.7 units at 45 degrees. The dark blue vector represents the sum, or the resultant vector. Its magnitude is 28.8 units. The angle of the resultant vector is 3.7 degrees, measured using a protractor. For coplanar vectors at 90 degrees, or perpendicular to each other, we use the Pythagorean theorem to find the magnitude of S. With values 10 and 15, S is 18.03 units.